Today we will go over section 1.4, limit of a function concept, and we will go more in depth with limits and apply what we learned. Previously, we did limits as it approached h and solved problems from there to find an exact value of the slope of a tangent or for finding the instantaneous rate of change. This time, it is the same concept, but instead of saying x approaches h, they will give you a number. So this number is notated by a over here. So we're not going to plug in h now, so we're going to plug in the number given. And the questions are going to ask you if this limit exists or not. So let's start by understanding this notation. So this notation, you read it as the limit of fx as x approaches a, which equals L. To understand it better, we can start with a graph. Let's say x is approaching 3, right? And my equation given is x squared minus 2. This time, instead of asking us to plug anything in, they will give it to you in the form of limit x approaches to 3, x squared minus 2, and ask you to determine it. Previously, we found solutions by plugging in h. This time in the place of h, I have 3. So I do the exact same thing, plugging 3 to the function. So that would be 3 squared minus 2, which will give me 9 minus 2, and it will equal to 7. And that will be my L in the notation. Another concept specific to limits is existing or not existing, as I mentioned. To find this out, you can think of limits being separated into two sections, right and left side. So if we go back to the example that we did right over here, we found L to be 7. So this is the graph x squared minus 2. So when x is 3, it's at 7. So this is my solution. When I say right and left side, you can visualize it as if they're separating it into two sections. So right side would be any values approaching from the right to the solution. And anything coming from the left side would be approaching from the left side to the solution. So my x is 3 and one section would be approaching from the left and the other one approaching from the right. The notation to show this will be the same, but now instead of writing 3, just 3, they will be shown by, for the left side, negative superscript over here, and the right side would be shown by positive superscript. So why that is because anything coming from the left side, if you look at the general graph, you can see it's coming from the negative side because these are like the negative side, and this is the positive sign for x where it's coming from the positive side. So that is the reason. An example we can do is the same limits we use. So when plugging the number this time, we consider their sides. So when plugging 3 approaching from the left, we'll put negative 3. And 3 approaching from the right will be positive. So if we do that, you can see my limits when I plug in negative 3 would be negative 3 squared minus 2, which would give me 9 minus 2 because negative times negative is positive, which will give me 7. And over here, I will plug in positive 3, so that will be 3 squared minus 2, which would give me 9 minus 2, which equals to 7. So as a result, my L will be 7 for both sides. When solved, if I get the same solution, then the limit exists. If, however, I get different solutions for each left and right side, then my limit does not exist. For example, in the problem we solved, our solutions were the same, therefore we can say the limit exists. Types of limit problems approaching from left or right are called one-sided limits. And sometimes it won't ask you, find if this limit exists, but can ask you to solve the limit specifically approaching from the right or left side. So let's go ahead and solve some problems. The first limit, it once x approaches to negative 2. So it wants us to plug in -2 for x. So I can automatically say 4 minus 3, -2 squared, which would give me 4 minus 3 times 4, which would give me 4 minus 12, and that would equal to -8, and that would be your solution. For this one, we can see for fx, my fx is only 4, so I have nothing to plug in. I don't have x approaching to 1. So therefore, in these problems, whenever you don't see an x, it just equals whatever is there. So if it's a constant, it will be a constant. For this one, it's the exact same thing. We plug in 3 to my x, so that would be 2 to the power of 3, and that will give me 8. So this question is asking for us to sketch the graph of the piecewise function given and determine limits as x approaches 1 f of x. So in these questions, the piecewise function gives you 3 different instructions. You can think of 3 different instructions over here. So when drawing these, I like to draw it as separating the graph into 3. So if I look at the first thing, it says x minus 1, and if x is less than 1. What I like to do is draw what x minus 1 is first. So that is what I drew over here. And then because it says x less than 1, I erase the parts of bigger than 1 or including 1. Because it does not include 1, what we do when drawing these is putting an empty dot right over here. The second one is saying when x equals 1, my function is 1. So that automatically means when there is 1 over here, my x is 1. So it's a filled dot this time because it does include 1. Lastly, the function 2 plus root x minus 1 is drawn like the blue arrow that I drew over here. That is my function, but it does not include 1. It's bigger than 1, but it's still like the first function does not include it over here, so I draw a not filled dot. So now in order to determine limit as x approaches 1, where it's fx, I can look at the graph and use one-sided limits. So if I try to solve what's coming from the right side, you can see that this function is included. It's coming from the right side. So I use my third function to solve that. So limit as x approaches 1 from the right side is 2 plus root x minus 1. When I plug in 1, I get 2 plus root 1 minus 1. And you can just eliminate right over here and just say 2. As like the same thing, when it's coming from the left side, which is right over here, it's coming from the left side, it's my first function, which is x minus 1. So in there, I'm going to plug in -1. So then I would get -1 minus 1 equals to -2. I can see automatically that these are 2 different things. One is +2, one is -2. So I can say, like I mentioned from the previous slide, that this limit does not exist. For this question, it's asking for the function fx, which is given in the graph, to determine the following. So the first thing is limit as x approaches -2 from the right side. So what I like to do in this question is, if you have a graph and it's saying x approaches -2, I just draw a line at -2, x -2 is which is right over here, and see what I'm passing through. So right now I can see I'm passing through the dot -2, 0. If it's coming from the right side over here, then it means my value is actually this one, and my y value is already given over here. So my solution would be 0. Remember in the previous questions, what we did is plugging in whatever the x approaches is given. So let's say -2 in this case, and we would be plugging it in to find the y value. So it's the exact same thing. Let's try for the second one. It says limit as x approaches to 2. So I automatically draw a line over here. I see that for this one, it passes through 2. So it either passes through the point 2, -1, which is right over here, and it's an unfilled box, or it approaches from 2, 2. So to differentiate between which one it wants, it already gives you that it's approaching from left side. So I can see that it's approaching from left side, that it must be asking for this point. And then I can say that my solution would be 2 since the y value is 2. Now for C, it's saying limit as x approaches 2. Again, it's the same thing as B, but now it wants us to find the approaching from the right side. So now that I can see my solution is approaching from the right side, then it must be asking for this solution. And the y value for this solution is -1. I just put -1 as my solution. For the last one, it's saying F2. So it's just like the graph question we did in the previously. It was saying previously like x equals 1, find it at 1, right? So it's exactly the same thing. I look at 2, x2, and I'm trying to find the y value. Remember, when it includes 2, when it's at 2, it has to be a filled dot. So from these two solutions, I can see this is unfilled, so it doesn't include 2. It cannot be there. So automatically I say, okay, my value is asking for F2 is 2. So my D, solution for D would be 2. Now that we're passing on to more integrated problems, so let fx equal to mx plus b, where m and b are constants. If limit x approaches 1, fx equals -2, and limit x approaches -1, fx equals 4, find m and b. So I can see my function is the same for both. What differs is in this one, it plugs in 1 and gets y value of the -2. And for this one, it plugs in -1 and gets the y value of 4. So from here, I can see I can have two different functions. So when I try that, let's start by plugging in 1 to the function. So if I plug in 1 to the x, I would get as my first function m plus b equals, bring this over here, -2. So that's my first function. My second function asks me to plug in -1. So if I do that, I would get the function -m plus b, and then bring in the y value from here, you would get 4. So I can see from here, I'm solving for two unknown variables. So when encountering two unknown variables, I can see that I have m and then -m over here. I can cancel these out. Therefore, just sum these up, and then you would get 2b equals -2 plus 4 would be 2. Here I can find b, which would be, if you divide by 2 each side, you would get b equaling to 1. So I already got my b value. Now I need to find m. Here you can choose any of the functions that we found over here. Doesn't matter, I'll go by m plus b since it's easier for me. I'll just say m plus, now that I know my value, I'll just plug that in for b value, and then equals -2. Put this to the other side, and you would be getting m equals -3, and that's my value for m, and my value for b would be 1. So for this question, it's asking to determine the real values of a, b, and c for the quadratic function fx equals ax squared plus bx plus c, where a is not equal to 0, that satisfy the conditions f0 equals 0, limit as x approaches to 1, fx equals 5, and limit as x approaches -2 is equals to 8. So this is a little similar to what we did previously, but now that you can think of having 3 different instructions over here to find 3 different values this time. Easiest one I can say to start with is right over here, because all you need to do is plug in 0 and you already know what you're gonna get. So if I plug in 0 to my function, I would get, if you plug in 0 over here, this cancels out, if you plug in 0 over here, this cancels out and you're left with C. And it already says that C value, whatever you end up with, will equal to 0. So I automatically found my C value. So my C equals 0. Now I can do the other ones. So you can think of your function being dropped to 2 values now, since C is we found to be 0. So I'm going to use this function now, ax squared plus bx. So limit as x approaches 1 would equal to 5. So I'll just plug in 1 and see what I'm left up with. So I would have a, and then if I plug in 1, it's just going to be the same thing. And then plus b, because x times b, just 1 times b is just going to be b, which equals to 5. So I have my first function. Let me do the second one. So now if I plug in -2 over here, I would get a -2 squared plus b -2. Right over here, -2 times -2 is 4, so I have 4a -2b. So that is going to be my second function over here, which would be equal to 8. Now we're going to sum up these values. However, it's not nice as the previous one that we can automatically cancel out, but we can still cancel this out. So there are different ways you guys can do. For this one, I'm just going to multiply it by 2 so that I can cancel the b's by -2 plus 2b. So I'm going to multiply it by 2. What I'm going to end up with is 2a plus 2b equals 5 times 2 is 10. And then I'm going to put the same exact equation, and now I'm going to sum these up. So I can automatically see I can cancel the b's. Now that I'm left out with 4 plus 2, excuse me, would be 6a, and then 10 plus 8 would be 18. To find what value is a is, I'm going to divide both sides by 6, and I'm going to end up with 3 for my value for a. I'm going to do the exact same thing that I did previously, plugging 3 to any of these functions of your choice. The easiest choice for me is plugging into the a plus b equals 5. So I'm going to say a equals 3 plus b equals 5. Put 3 to the other side as -3, so you would get b equaling to 2. So I found that my a value is 3, b value is 2, and my c value is 0. Last question. The fish population in thousands in a lake at time t in years is modeled by the following function. I can see that it's a piecewise function. This function describes a sudden change in the population at time t equals 6 due to a chemical spill. So from this description, I'm already expecting a sudden change at time equals 6. What I mean by that on the graph, what I'm expecting is when it's at 6, which is our x, I'm expecting it to have a dot right over here, like a higher y value, and then it drops suddenly to over here. I'm expecting an empty dot or empty dot because it does not include 6 over here. So we did this previously. We saw maybe like something coming like this and then something going like this. So from the description, I can already see that the population will drop because it says it's a chemical spill. So it indicates a drop in the population. The first question is to sketch the graph of PT. For the first piecewise function over here, it's between 0 and 6 and including 6. So I can say at 6, it's going to be a filled dot, and it's starting from the y value of 3. So I can start it right over here. And I know because it says squared, it's a parabola. So it's going to be something along these lines. So it's going to go something like this, and here is my filled dots. For the second one, it does not include 6, but includes 12. So it starts from 6, an empty box, but it starts from 2. My y value is 2. What I do usually with these is drawing the whole function. and because it says 1/18, I know it's going to be wider, so it's going to be something along these lines, something like that, let's say. And if this is 12 over here, it's going to be a filled dot, and here it's going to be an empty dot, and I'll be erasing everything up here because the function does not exist over here. Why I draw the whole function is it's because it's easier to draw the whole thing, therefore it eliminates the mistake, and then you can just look at the look at the conditions given and erasing accordingly. So this is going to be my graph. Like I said, the jump is there, and that is your solution for A. B is asking for us to evaluate limit t equals 6 approaching from the left side and limit t approaching to 6 from the right side. We did this before. For limits approaching from the left, I can see that it includes this function. So what I'm going to use is the first function. So I'm going to plug in 6 to the function 3 plus 1/12 t squared. So when I do that, I will get 3 plus 1/12, 6, -6, because it's coming from the left side, squared. And from here, I can see 3 plus 1/12, 6 times 6 is 36. 36 divided by 12 is 3, so therefore it's going to be 3 plus 3, which will equal to 6. So for coming from the left side, my solution is 6. I can see for the second one approaching from the right side, it's approaching from here to the solution, 6. And I can say that it's the second function right over here. So I'm using 2 plus 1/18 t squared, plugging positive 6 for t, you would get 2 plus 1/18, 6 squared, which would give you 2 plus 1/18, 36. 36 divided by 18 would give you 2, so 2 plus 2 would give you 4. For section C, it's asking for us to determine how many fish were killed by the spill. So these limits we found in B represents the drop. So what we found is the y value for these solutions approaching from right and the left side. So for this solution specifically, it's representing from the left side, so it's 6. I can already say my y value over here is 6. And over here, this represents coming from the right side, so it represents this solution over here, which I can say this solution would be after the chemical spill, and over here actually supposed to be a little bit higher, so I'll just put the 4 over here, but just if you have a graph where it's higher, just imagine that it's like right over here somewhere, but I'm not gonna change that. So I can already see that for t in years, it says the fish population is represented by thousands. Our fish population is our y over here. So I already have what y value was before the chemical spill, and I already have the y value after the chemical spill. All I need to do is, because it says 6 for the first one, it's actually 6,000, and for the after the chemical spill, my y value is 4, so that means it's 4,000. So if I say minus 4,000, that's going to give me how many fish were killed by the spill, which is going to be 2,000. Where last one, it asks at what time did the population recover to the level before the spill. So the level before the spill is actually where the y value is 6. So we're just going to say after the spill is where it's represented by the second function right over here. So I'm trying to find at what point, what time over here that the y value will equal 6. So we're trying to find for this point over here. So what I'm going to do is use the second function, 2 plus 1 over 18 t squared, and equal it to 6, which is the y value we're trying to find. Put 2 as negative 2 over there. I have 1 over 18 t squared equaling to 4 times 18 both sides to cancel these out. So this is gone, times 18. My t squared is equal to 72. Root both sides and I would get t equals 8.49. So in years, my t value is 8.49.